Okay, so today we did the second to last lesson of this unit, lesson 24, unit 2. Tomorrow will be the last lesson, and then you'll have every bit of information you need to do well on this next unit test. So some of you just really need to practice and stop trying to cheat your way through it. Sometimes I notice you cheating and I just let it be because you'll learn. You'll learn that you can't cheat on the test and you'll just fail that test. That is worth way more than any quiz, way more than any homework. Some people cheat on the quiz and then they don't even do that well. Like, get it together. If you can't even get the right answer by cheating, you really need to dig deep and figure out what is wrong. And this hour that we have together, additionally, is not so that you can just get answers from your friends on the homework and then play games the rest of the time. I do have a list of all the people that used it as free time yesterday. You guys in this class had the whole hour to do IXL skills. You had to send me 5 of them through the link in the algebra Schoology. Some of you sent them to me. A lot of you didn't. So, Miss Medina. What math test are you talking about? So yeah, I mean, the instructions yesterday were very clear. It was do IXL, and then should you have extra time after that, then do your study guide. Some of you spent the whole time doing whatever you wanted, and know that should your parents ever ask about you, I certainly don't lie. I say, oh yeah, they just watch movies in here. They don't do their work. It's a big waste of time. Oh yeah, they have an F in math lab because they're not doing their work. I'm not gonna lie. And certainly, I'm not here to babysit you. I'm here to teach you math. You'll never have access to another teacher like you will me. You will never have another math lab. There are no math labs after this. If you want extra help in math, you either have to get your parents to get you a tutor, which costs lots of money, or you need to go to the free tutoring that your teacher offers, if they offer it. We don't have to offer it. So I don't know, get it together. Stop trying to cheat your way through it. We need more than a 10% to pass this class. Homework is only 10%. So anyway, today we did lesson 24, and that is systems of linear inequalities. Up to this point, we've been just looking at them separate. So constraints separately. Now we're putting them together. So a system requires a minimum of how many? 2. So if on your constructed response, for example, which I have a practice test right here, if anyone ever wants it early, if it says create a system of equations or inequalities, you need to have at least how many? 2. And it says equations or inequalities because in the past we taught this as just one big unit, not 2 separate units. You know, on your constructed response, you need to make a system of inequalities this time. So you have 4 different options for your inequality symbols. Which one you use depends on which one makes the most sense. So if I said, for example, I'm trying to think of words that. If I said we need at most 36 students to go on a field trip, then can I have more than 36 at most? No, so then I'm going to flip the sign. At most says that I can have less than 36, right? And if it's at most 36, can it be exactly 36? Then that's where that little line play. That's how you choose what symbol to use. The rest of it should be reviewed from the last unit. Although I know word problems can be hard, I get it. Start with your totals, then see what contributes to that total. So I don't know. I can't make a expression for this. Maybe S is for students. But maybe the word problem is saying that X will be students from Miss Medina's class, and Y will be students from Miss Torres's class. Who knows? But whatever is contributing to that total, you need to write as an expression. Typically, one of your expressions in your system is really easy, like x plus y. The other, because I feel like a lot of the time they like to talk about money. Think logically what contributes to it. Most of the time, it doesn't really look different from our standard forms. It's usually ax plus by. There can be different things, but I don't think we've seen that. It's the way that some of the word problems are. So that's the skill. You know that you can find a lot of things by just typing it into Desmos, but if you don't know what to type in, then that's not gonna help. So that's the hard part, is coming up with it from a description. So you're gonna practice that through this practice. That's what I expect everyone in here right now to get 80% or higher on. Then you can go back and do all the other stuff like I said. Especially if you have a bad grade in here, do the things that are worth more, like the assessments, the projects are worth more than some of the other things. Mastery goals. Okay. You have a tab in Schoology called grades for any of your classes. You can click on it and it'll take you directly to that assignment that you need to do or do better off. But that's what this hour is for. Some kids get their things done all the time, and I don't mind if those kids have their free time, but others of you are just wasting the day and the opportunities. So make sure you're genuinely getting 80%. Questions? Okay. So ask as you go. Otherwise, I'll check in the last 20 minutes or so. Okay, so you can continue working quietly by yourself if you don't need help, but this is today's practice number 4, and we're selecting the correct choices to complete the sentence. So here's a graph. Is the region that represents the solution set to 3x plus y less than 9 correctly shown by the shaded area? So that one, we would want to first make sure it's in slope-intercept form before we look at the shape area. And yeah, you can probably do tests in Desmos, but you won't have that for your state test, so make sure like you can still do it. If I want this to be in slope-intercept form, what would I have to do? Okay, and how do I make it like y? Okay, isolate the y. How do I get rid of the 3x? And whatever you do on one side of the inequality. So then in slope-intercept form, it'll be this, y less than negative 3x plus 9. I did not have to flip the sign at all because of the, all I did was subtract, so I didn't divide any negatives or anything like that. So looking at it in slope-intercept form, whenever it's y less than, do I shade above or below? Good, because we're saying that. So look at the number line for the y axis, it goes up and down. If my y-intercept is 9, we're basically saying I need a shade where those y values are less than 9. So it looks like this one must be the line. Is this line shaded below? Yeah, it is. The blue is the shading below that line. And I'm looking at my y-intercept so I know what line to look at. And yes, it is shaded correctly. Then it says, is the boundary line part of the solution? Well, our boundary lines for both are solid or dashed. Are dashed lines ever part of the solution? No. So we're going to say no. Because if it's on that line, then it must be I don't know, say it's like 10 less than 10. We know that 10 is not less than 10. So, no. Is the region that represents the solution to the other inequality correctly shown by the overlapping shaded area? Is that boundary line part of the solution? I'm gonna already say no to that one because it's dashed. And then which point in the solution to both? So to see that that one's correctly shaded, I'm gonna scroll back up. 3x minus y less than 9. And that one I need to put in slope intercept form before I check the whether it's shaded right or not. So what would I have to do to this one to make it slope intercept form? By doing what first? Okay, good. So starting to get the y alone is negative y having the y be equally alone. Like is the y alone right now? Technically, no. We want it to be not even with a negative in front of it. So right now it's a negative 1y. What's opposite of multiplying negative 1? That's what I'm going to do next. And whatever I do on one side of the inequality. Okay, good. And that is something that causes the inequality to flip. So now it's going to be y greater than, this becomes 3x, positive, good. And what's 9 divided by negative 1? So we need to see if it's shaded correctly. Here is the y-intercept of negative 9. Did they shade above this line? Yes, this is above because these y values on this side versus like below that side would be greater than the negative. And that's shown by like the hash marks, if you will. So we will say, yes, that is correctly shaded. And the last part is which point is a solution. So either negative 2, 5 or 3, 5. Let's see. Negative 2, 5 would be here. And sorry, I already forgot it. 3, 5, I think it was, would be there. So solutions to systems are where? Where they are both shaded. So if they're shaded like this, then I should be looking where there's hash marks and blue. So which one's the solution? The negative 2, 5 or 3, 5? Good. So it has to be in that overlapping shaded area. Right, let me make sure the key is right. I'm pretty sure all our answers are right. And yeah, the key is right. So questions on this one? Cadence? Okay, but are we good with this question here? All right, cadence. Number 2 on these activists. Okay, so select all the pairs of x and y that are solutions to this system. So you have a few ways to go about this. We know that solutions to equations and inequalities make the statement true. And if we want it to be solutions to the system, they have to make both true. So that's a lot of plugging in if I'm doing it algebraically, because I do have to select all. So what I would recommend, like if this popped up on a test, is to use Desmos. It's not like on this one you have to make it from scratch. So we're going to use Desmos for this one. I'm going to type in the inequalities, exactly how they look. All right, now I'm going to look for my answers to be in the overlapping shaded area for it to be a solution to the system. In order to see that a little bit better, I'm going to write them in coordinate form. So you would have to know to do that. Like, right, that the x comes first, the y comes second. As a coordinate, you put a comma and parentheses like that. So is this one a solution to the system? No, it's only in the shaded area for one of them. So no. Let's try the 0, 0. Is that one a solution? So you guys, I think, should be able to do the rest of it. If we need to come back to it, that's fine. But using that process, type in both, see where it overlaps. If it's ever on like so this is a good example because you kind of have both. This has popped up on a test before. If it's on a solid line that is touching the overlapping shaded area, so maybe something like that, then that would be a solution. If it's on a solid line touching the overlapping shaded area. If it's on a dashed line, it is never a solution, never. If it's on like the intersection right here, where it's touching the overlapping area, but it's on a solid and a dashed, remember, on a dashed is never the solution. So like that would be a no. Okay, questions on this one? Okay, questions on any others? Cameron? 7 on today's practice. Okay, so we have Elena's considering buying bracelets and necklaces as gift for her friends. Bracelets cost $3, necklaces cost $5. She can spend no more than $30 on the gifts. Okay, so they give you the inequality that represents the situation. You need to complete the following to explain how you could check if the boundary is included or excluded from the solution set. So the boundary blank, because the coordinates of the points on the line either satisfy or do not satisfy it. And it gives you one to plug in. So for example, 0, 6 means, hold on one second. Okay, so I'm going to use the coordinate that they identified, and for some reason it's not letting me write on my screen, so that's kind of a bummer. Hang on. Yeah, I don't know why it's doing that. Hold on. Okay, now it's loading. All right, so they're saying that the 0 is for the bracelets and the 6 is for the necklaces. So this is essentially how they're ordering it. So when I do go back and plug it in, it's going to end up being 3 times 0 plus 5 times 6 less than or equal to 30. We're going to evaluate that. What's 3 times 0? Okay, so that term basically cancels. What's 5 times 6? And we're seeing if it makes it true, then it's the solution. So is 30 less than or equal to 30? Yes, because of the equal to part. It has both. It can be less than or equal to 30. So the boundary is included because of the solid line underneath. But for this, it does satisfy the inequality, meaning that if I have 0 bracelets and 6 necklaces, which would cost $30 and is still within her budget. That's using her entire budget, but that is a lot. So questions on that? sure the key is right and his. Other questions or anything? On the 24 practice. Yeah. So Jada has $200 to spend on flowers for a school celebration. She decides the only flowers she wants to buy are roses and carnations. Roses cost $1.45 each, carnations cost 65 cents each. Jada buys enough roses so that each of the 75 people attending the event can take home at least one. Okay. So which inequality represents the constraint that every person takes home at least one rose? So I'm rereading it. There are 75 people attending the event. So if she wants every person to take home at least 75, can people take more than 75? Can they take exactly 75? If the phrase is at least. I would say yes. See what our options are. So yeah, I'm gonna go with that one. Because at least 75 includes that. If that's an error on the key, then I'll fix it. But when we say at least, we can have 75. That's a minimum. Then it says which inequality represents the cost constraint. So make sure you know the difference between the constraints. Like the cost constraint, I need to look at the cost total. What's the cost total? $200. So she has $200 to spend on flowers. Does that mean she could spend greater than 200? So then I'm gonna flip the sign around. Can she spend exactly 200? So then I'm gonna put the equal to. Let's see if that's enough. And it is. The only difference between these are the symbols. And that's the one that matches what we said. Let me make sure you get it right. And it is. So that one is testing you on can you identify the right total and what could be greater, less than, or equal. Questions? Any others? So again, no reason we can't get, I mean, I think there's no reason you can't get 80% or higher wrong in here, but there's no reason I shouldn't have like zero conventions at all. Just did a good chunk of them. Might have even been all of them, but enough to where you could at least guess on the other one, at least one. Any other one?